All right, so what we're going to do today is we're going to have a look at how to solve application problems. Now, a lot of this is the same for what happened when we solved Pythagoras applications, all right? So it's just we're going to have some angles in there as well, okay? But exactly the same process. Okay, so the first thing is you've got to draw a picture. Now, some of you got a little bit slack at doing this. Don't think I didn't notice. Okay, so you've got to draw a picture, especially if none's given, or check the picture and say, and label it with the sides you've been given. Or sometimes the picture is so complicated you want to just draw a triangle with the information. Okay, here's an example. Find the missing sides for triangle FRY, given that angle Y is a right angle, F equals 68 and Y equals 88. Now that's really hard until you draw a triangle. Okay, so here's the triangle associated. So what I did is drew the triangle FRY, and then I knew that whatever Y was had to be the right angle. Okay, it had to be a right angle triangle to start off with, and then managed to put the two sides on. Okay, it's a little bit obscure, that one, but we'll get on to some real problems. Okay, so don't worry about the tan down the bottom, that's just reminding you. Okay, so we've got a castle here. So from a point 80 meters from the base of a tower, the angle of elevation is 28 degrees. Now, angle of elevation means the angle up from a horizontal. So we're asking how tall is the tower? Okay, well, that's 80, right? And there's the 28 going on. And if you have a look, there's the triangle. So we're wanting to know how tall this is. Now, if you have a look very carefully, we have an angle. We're wanting a opposite side, and we've got an adjacent. So we pull the triangle off. There we go. All right. And opposite and adjacent. So therefore, we're going to use tan, aren't we? So there we go. There's the formula. I'm going to chuck the numbers into the formula, rearrange it, and I get 42.5. Now, because it's a word problem, I need to think about my rounding for this. So it's about 43 meters tall. Okay, the reason I've chosen 43 is because this one here was 80. Okay, and so that's in a whole number, so I'm going to use a whole number for my answer as well. Notice I've also got the unit on the end. That's really, really important, isn't it? So my right angle didn't move, so let's just pop the right angle in case you're wondering. There we go. Got stuck over by the tower. Let's have a look at the next one. Ladder that is 20 feet is leaning against the side of a building. If the angle formed between the ladder and the ground is 75 degrees, how far would Miss Wilson have to crawl to get to the front door when she falls off the ladder? Assuming I fall to the base of the ladder. It's fair. No, I'll probably go straight down. But anyway, let's just go with it. There we go. My ladder. Good-o. There's the triangle. See it? Oh, okay. Moving the triangle away. Let's put the measure. There's the ladder. There's the building. We know the ladder's 20. We know the angle down there is 75. And we're looking for how far this is. In other words, how far do I have to actually crawl in the door after I fall? I'll be crawling because I'll have broken most of the bones in my body. Okay, right angle. Oh, so I did put that one in. That's good. Okay, so it's cosine. We've got the hypotenuse and the adjacent side. So at this point, just becomes a straight trig problem. Let's load her up. Done. Yep. No, you don't need the bracket in case that's the next question. And 5.2. So about 5 feet. I'd have to crawl about 5 feet in to get in the door. All good? Let's have a look at another one. When the sun is 62 degrees above the horizon, a building casts a shadow 18 meters long. How tall is the building? Now, this is quite a useful one because you can actually use shadows to work out how tall things are. And people actually do this. Okay, especially when you've got trying to find heights of big cliffs and things. It was too hard to do. You couldn't measure it. So, but you can actually use the ratio. Very clever. Oh, look, there's the sun. Look at it happy. There's my house. Okay, there we go. That's the triangle we're looking for. Okay, there's the shadow on the ground. Okay, and it's 18 meters long. That angle there is 62. All right, and we're looking for that length. So, oh, interesting. It's tan. Now, look, tan often comes up in at trig problems or real life applications, just because we often have a vertical and horizontal. It's that diagonal that's a pain in the ass to measure. So it's all good. All right, let's go. We know that. Yep, load her up. You know what to do in the formula. Beautiful. Notice I put the formula down, then I've loaded into the formula. Let's do the rearrangement. Whew. Bob's your uncle. 33.9. It's about 33.4 meters tall. Cool, eh? Kind of a useful thing to be able to do. Okay, right, a kite is flying at an angle of elevation of about 55 degrees. Don't worry about the sag in the string. Now, this is very important. Don't find extra things that can go wrong, like, oh, what if the string's not straight? Or what if the sail's kind of bendy? None of that. Or what happens if Miss Wilson doesn't fall directly at the base of the ladder? Don't worry about that. Just read the bits you've got. Okay, there's the kite. Oh, there's the triangle. Yeah, grooving that one. Look at that red triangle move. There's, okay, and there's the information on it. 55, string, 85, we know that. Good, I'm looking for that. I actually want to know how high the kite is above me. Okay, there we go. And so this time we know the hypotenuse and the opposite. It's an unusual problem, but because we know the length of the string, it's actually easier to find. Okay, we won't be using tan this time. Okay, whoo, sine, here we go. You know what to do. Bonza, and we've got that. It's about 70 meters long. Kind of cool. Okay, now depression and elevation. You might see this around, just so you're clear. Okay, if you look up from anything, so if you're looking up from a horizontal, it's called an angle of elevation. So that's the little red line that's just gone in now. Okay, all right. If you're looking down on something, you look down from a horizontal, that's that second red line, and that is known as the angle of depression. So if you're looking up from a horizontal, so you're staring out, looking up to something, that's elevation. Staring and looking down to something, that is depression. And look, there's a set of parallel lines and a transversal. Ooh, know a few rules about that. Okay, so here we go. All right, so the angle of depression from the top of a tower to a building is 38 degrees. So they're talking about that angle there. Okay. If the tower is 25 meters high, how far is the base from the boulder? Now, we know from parallel line rules that this is like a zangle, right? Yeah. So if that's 38, then this here is also going to be 38. Funky, yay. Right, okay, there we go. Let's put the information. So I'm looking for this distance along the bottom. We know the height of the tower, okay? Yeah, oh, sorry, zangle. Alternate angles on parallel lines are equal, as we know. Okay, so here we go. That one's 38 degrees, and away I go. Here we go, opposite and adjacent. So that's obviously got to be tan. Let's shoot her up. Got it. Oh, yes, it's about 32 meters. All right, got it. Draw a picture, label the picture, do the trig. Good luck.